Okay, so as you're kind of finishing that up, I'm going to start talking on this stuff. So we're going to move on to chapter 4. Chapter 4 is all going to be about these matrices, or matrix is the singular version of that. Basically, what it is it's just like a rectangle of numbers, and it's arrangement of objects. It calls them elements, but usually it's just going to be numbers, or sometimes it's letters if it's like variables and stuff. But it's just a way of like arranging numbers so that we can do operations on it. Like we're going to do adding with them, multiplying. We're going to end up doing some stuff where we do like reflections and rotations and that kind of thing, kind of like what we did in geometry. But it's just a way of organizing basically a set of data. Um, when we do this, your dimensions of it are always going to be, so they call it M and N here. Your M value, whatever the first number is, that's always going to be your rows. So here are rows, you can kind of see how that matches up there. There are two rows here, so that's why our first number is 2 for our dimension. And then there are 4 columns going across there, so your columns number is always the back number there. So that matrix, the dimensions would be a 2 by 4. Okay, and that's going to be important when we get to some later stuff, because when you add, the dimensions have to be the same, and when you multiply, there's a special rule with the dimensions too. So it's good to know where those numbers come from. Again, the rows is the first number, and then the columns is the second number for your dimensions. Okay, so looking at our first example here, did everybody get one of those new packets for chapter 4? Okay, so that should be in that packet there. So cell phone company offers a family plan and an individual plan. 5 years ago, the company had about 6 million family plan members, 9.4 million individuals. And then 3 years ago, there's 11 million family, 8.8 million individual, and then 13.6 million family and 10.2 million individual in the last year. Okay, and we're supposed to store this, store the membership information, or like, who's in what plan and whatever, in a matrix. Okay, so I'm going to show you 2 different ways you can set this up. One of them is kind of like a long one where it's going to have our years out front here. So you just put like whatever your labels are on the outside. So like I'm going to go like 5 years, 3 years. And then the last one there, it says last year, so I'm just going to make that 1 year ago, or just 1 year. And then our other pieces of information would be differentiating between the family plan and the individual plan. So my label across the top, I'm just going to do F for family plan and I for individual plan. And then what I'm going to do is I'm just going to take the numbers that correspond with that information, and I'm going to put it in the spots underneath it. So like 5 years, I want to get my information for family and individual. So like 5 years ago, for the family plan, it was 6 million. And then for the individual, it was 9.4 million. So I'm just going to put those numbers in. So 5 years ago for family, I'm just going to put 6 because they're all in millions. And then individual was 9.4. And then I just do the same for my 3 years. So for at 3 years, it was 11 million for family, 8.8 million for individual. So family 11.5, individual 8.8. And then the last one was last year, so that'd be like 1 year ago. 13.6 for family and 10.2 for individual. I wasn't even highlighting those in the spots that went. So those, whatever color I did first, those went there. Second color was that second row. If you want to look at the colors, I don't know. I just had colors on my example sheet, so that's why I did it. 13.6 for family a year ago and 10.2 for individual. Okay, so that's one way to store that information, okay? Another way we can do it is to change where our labels are at. So instead of having the 5, 3, and 1 up and down on the side there, we could also put those across the top. So you could do it like 5 years, 3 years, and 1 year across that way, and then just make it like a little bit shorter, and then just make your 2 rows family and individual. and then you could just take those same exact numbers and put them in there, so it's still 5 years and family, so still 6, 5 years individual, 9.4, so those are our same first two numbers we had. And then you can put your 3-year information in there, so 11.5 for family, 8.8 for individual. And then the last one for 1 year, 13.6 million for family, and 10.2 for individual. So just depending on if they specifically say something like, hey, it's got to have these dimensions, or you got to have this as your rows and this as your columns. Sometimes they might tell you, what's what, and sometimes you might just get a choice, and you could set it up either of those ways. I'm going to put an or in there. Either of those ways would be fine. If they just say it like that, just set up a matrix for that. Okay, and then part B of that wants us to give the dimensions. So what would the dimensions of this first one we did be? 3 by 2. So it's always your number of rows. So we've got 3 rows there by our number of columns. So that first one is a 3 by 2. And then our second one there, what's our second one? 2 by 3. So our other one was a 2 by 3. Okay, so those were our two options. So that went with that one with that one. Okay, but either way, those are fine. Like I said, sometimes they might say, put it in a 3 by 2 matrix and then you do that one, or put it into 2 by 3 matrix and then you do that one, but if they don't say, either's fine. Okay, next set of stuff here. Got that down. And this matrix stuff, for the majority of it, it's not too bad. It's all different because we've never done matrices before. But once you get the hang of setting them up, it's really not too bad because there's a lot of stuff we can do on the calculator to kind of make it easier. But you'll definitely want to know the calculator steps out and how to plug it in and that kind of thing, which I think we start working on in the next section. So just make sure you bring your calculator charge tomorrow because I'm pretty sure it's the next section we start working on that. But you can do the stuff by hand too. Some of it's easy to do by hand, some of it's a pain, but this section, it's new stuff, but it hopefully shouldn't be too bad of stuff. I think you'll pick up on it pretty quickly. Okay, so equal matrices, so this only works, so if and only if they have the same dimensions and corresponding elements are equal. So this only works if they're like exactly identical to each other. So even though on that last one there we had like 2 matrices where we used the same exact numbers, if we don't set them up with the same exact dimensions, they would not be considered equal matrices, okay? They have to be identical. All the numbers have to match up, and they have to have identical dimensions to each other to be equal matrices. So even if you use the same numbers, that doesn't consider those equal, okay? Next thing there, point matrix. So we're going to use this quite a bit. So it's basically using a matrix to represent ordered pairs. So the first row is going to be all of your x values, and then the second row is going to be all of your y values, and then the ordered pairs that stack with each other. So like this x goes with this y. If there was another x there, that x would go with that y, and they're just all stacked up with each other. Okay? And that's actually what we're going to do with the next thing there. Is that activity in your little packets? Okay, perfect. So we're going to do that activity together here next then. So it says pentagon ABCDE with vertices. Again, vertices are just corners, and then it gives us a bunch of points there. So we're probably going to want to take all those points and graph those out first, just to kind of see what it looks like compared to our other stuff that we're going to get when we go here. So let's just start by graphing this, and I would label it as you're going as well. So A is at 3, -5. So just put a point there, label it A. And then just kind of keep working your way around there. We should all know how to graph. On the half ones and the 3.75 ones, just do your best to kind of eyeball where those are at. Okay, and then I just connect those just like we usually would. Make your pentagon. You don't have to use a straight edge. I just got my straight edge up here. And we know we connect those in the order that they give them, right? So like A to B to C to D to E. Should get something that looks fairly close to that. Okay, and then for the activity, it wants us to kind of walk through some steps here. So the first step, write a matrix representing the coordinates of the vertices of our pentagon here, starting at point A. So you just start by making your little bracket there for your matrices. We're going to start with A, and then I'm just going to work it in that order there. A, B, C, E. I don't know why I did E. D comes after C in the alphabet, and then E. And then for these, you just take whatever the ordered pair is. So like for A, it's 3, -5. You just put your 3 on top, -5 on the bottom. B is 6, -1. So 6 on top, -1 on the bottom. And then you just do the same for the C, D, and E. So 4, 5 for C. D is -2.5. 4. E is -5, -0.75. So that would be your matrix that represents that. And then it wants us to write two other matrices representing that same pentagon there. So how else could we write that? Like when we name a pentagon, how else can we name it? Do we have to start at A when we name it? Okay, so if we do it backwards, so if we went from like E and we did backwards, if we went like E, D, C, B, A, would that be a name for it? Yeah, so we could do that. So like writing that out matrix-wise, if we start at E and then go backwards, E, D, C, B, A, and again, going around in that order is important. Then we would just write our ordered pair for E. So E is -5, -0.75. D, -2.5, 4. C is 4, 5. B is 6, -1. And A is 3, -5. So that would work. We could also name it that way. It wants two other ones here, so what's another way we can name it?
Can we like start from like C?
Sure. Which way you want to?
Would it be C, D, E, A, B?
Yep, that would work. So if we go C, D, E, A, B, that should be fine. So C would be at 4, 5. D is at -2.5, 4. E is -5, -0.75. A is 3, -5. And B is 6, -1. Yep, that should work. And then the last one there says explain why there must be something else for step 3 that we're just skipping. But it says explain why A, B, C, D, E does not describe a pentagon. What do we think there? Why can't we go A, B, C, D, E? Yeah, so like if I went around in that order there, so if I went like A, B, C, and then D, E, and then I'd have to go back to B because that's where I started, right? What's going to happen there? Did that make a pentagon? No. So because it's not going in order, or because those two segments kind of cross each other, that wouldn't work for this. So you could say like, well, I guess it says why does it not describe a pentagon? So we can't say it's because it doesn't describe a pentagon. That wouldn't make sense. We could say something about those segments crossing each other. So like segment, so that's with the little bar over top of it, CA and EB cross each other. Or you could say not connected in the correct order. Something along those lines would be alright. Okay, so that's basically it. Hopefully not too bad. Like I said, it's new stuff, but the general concepts of it aren't horrible. Okay? Alright, so working on that book page there.